You're muted, Roger.
I hate myself. Uh, I've been talking the entire time. Hey, welcome everybody. Here is the attendance sheet for today. Thank you for that reminder. But welcome everybody to Intro to Coding Live Day 3. We're going to pick off from where we left off yesterday, and we're going to be covering Python ordered data structures. Um, Before we do start, I do want to make sure that something's clear. All right, so everything that we're covering within this curriculum, for the most part, it's all going to be tested or testable, or it's going to be applicable for your assessment, right? The only thing that I would say that probably wouldn't be applicable for you guys would be functions. We don't necessarily look to see how proficient you are with functions. So if you feel like yesterday was very overwhelming with all the functions talk or trying to understand how functions work, we're not going to expect you to write functions during the live technical interview. Uh, Really, what we're looking for is variable assignment and reassignment, which was covered in day one. We're going to look at lists and dictionaries, which lists is covered today. Dictionaries is covered Monday. We're going to talk about how to, you should be able to access and modify both lists and dictionaries. Um, and then the last thing that will probably be tested or asked of you to do in the live technical assessment is going to be for loops or loops in general, right? So the problem that's going to be administered to you is going to have um, the structure that's going to kind of force you to use some of these methods, right? So as long as you feel comfortable with those, four things there, you should be in good hands, right? We're not going to ask something crazy for you to do if it hasn't been covered. The structure of the curriculum is made to ensure that you are successful in the live technical assessment. The only thing that you guys have to do is really just study the material and understand it, right? So I encourage you guys that you are completing the assignments that are here. Nothing is graded, right? I don't check your assignments. The version of the curriculum that you have in your code space is not tied to anything. It is on your own GitHub. You created a copy, so I don't have access to it. Um, so no one's gonna grade you for it, but it's good practice, right? So if this is the first coding language you're learning, definitely ensure that you are completing the exercises to ensure that you understand the material. And if at any point you feel like you have any questions about something, I encourage you guys to reach out, right? This is what I do. So if you guys have any questions, I'm usually available. I work from home, so I work during the day as well here on my computer. And if you guys have questions, it's not foreign for me to pull aside and jump into a quick Zoom call with you guys for 30 minutes to even an hour. I've been in calls with people for over an hour at times too, just trying to ensure that they really understand what they were struggling with. I say that because no one reaches out. No one has reached out at least. But I'm here, right? So take advantage of it. This the beauty of taking part of the Intro to Coding Live is that you don't have to struggle in silence, right? I am here for you guys if you have any questions.
A piggyback to what you were just talking about for the live coding aptitude. If, say, we get mixed up on like syntax, can we explain what we're trying to do and get a push that way, or are they going to allow us to like go to like that one website you were using, like the W3 schools or whatever, and like look at the syntax to see if it's like string dot something or if it's something like length to where you have to pass in an argument, for example.
That's a great question. So there's no notes, so you can't go to W3 schools. Ideally, as I mentioned, you want to ensure you have, you understand some of these methods that are going to be helpful to you, which is why I tell you, this is a good method to keep in the back of your pocket or to remember because it's going to be very helpful. So make sure that some of these methods that you feel that might be helpful to you, you kind of are aware that they exist and mess around with them. In regards to if you get stuck, right? Syntax wise. Yes, you do get a push, right? We don't want people to fail necessarily, right? we're not going to pass you if you don't understand what you're doing. But at the same time, we also understand that you guys are brand new to coding. And if you have an idea of what you're trying to accomplish, but you're kind of stuck and you're not sure exactly how to get there, it's not uncommon for you to get a little push like try this or try that, or you know, kind of give you a little nudge towards the right direction. And then try to get you back on the road to solve your live technical assignments. Does
You
that answer
did
your
say,
question?
yeah, it does. You also said no notes, but would something built in be allowed, such as like print, I think it's like KW list.
KW list, I'm not quite sure what that is, but in regards to print, well,
I
could
believe it accesses the internal database of the keywords for Python.
um I mean if you type in a function and you want to remember how it works, if you right click and check definition, I that's a great question. I'm not quite sure. Maybe. Uh I mean if you're aware that you can do that, and I was grading you, I don't see why not. But if you're looking for like if you're Googling something, then that's like all right, that's a red flag, right? But that's a good question. And that's probably a much better question to ask the instructor, which I will have here next week for you guys, so you can ask all these questions to him directly. Um, Hopefully that answered your question, Thomas. All right, so today we're going to be talking about data structures, right? Um, Up to this point, the only thing that we really covered was like variables and assigning values to them. But what if we have a situation where we have multiple variables that we want to take into account, right? And you've kind of already seen a small little snippet of it on some of the additional extras. You've probably already seen that there was a list in there. Um, that's done purposely so you can kind of do some research on your own, see like, oh, what is this? How do I access it? Hopefully piquing your interest and seeing if you can go out there and do a little bit of research. But today we're going to officially cover it, right? I've shown you some small demos when doing some small demonstrations when you guys have asked your questions. And now we're actually going to start talking about them. And the first order data structure that we're going to be talking about today is going to be lists, right? So the term the ordered data structure is not given to it for no reason. Ordered data structures are called ordered data structures because they have some form of sequence, right? As you're already familiar with strings, when talking about the positions of characters in a string, we work with index notation starting at zero, so zero index notation. And ordered data structures are going to work the exact same, right? So here we see the image again. You've seen it before of how the string is kind of structured, right? The P in string is at position zero, and then Y is at one, and the increments for every other character. Lists are going to work exactly the same. Um, the cool thing about lists, though, that strings don't offer you is that you can change lists, right? So when you remove or add or change a value in a specific position, it will change. It won't recreate a whole different list. There's actually some built-in functions to allow you to manipulate the list, make it easier, and we're going to be talking about those. And with that topic, it brings me to the fact that lists are mutable, right? Because you can change certain values at certain positions. That means that list is a mutable data structure. That means you can change it. You are able to update it, remove it, or even overwrite everything within that list. Now, the syntax for lists are pretty straightforward. Lists are declared by using square brackets, right? So there's two ways of creating lists. One way, which is probably the least common way, and I don't know why people would do it this way, is by calling the keyword list and then using open and close parentheses. So this is a way that you could declare a list. You will probably never see anybody doing it this way, but it is possible. This will create for you an empty list, right? It's almost like calling a method or a function like you guys saw yesterday, right? When you call a function, you call the name of the function, and have open and close parentheses. This is really just going to return to you a list, um, but you won't really ever see it written this way. Usually, when people create lists, uh, they will do it with a square brackets for open and closing. If you were to create an empty list, you just wouldn't pass any kind of value within there. But typically, when you create a list, you have an idea of what you're trying to put in there as well. So it is pretty common to start a list with some predefined values in there. For those of you who might have some familiarity with like Java or C Sharp, lists are typically not exactly native. I think you have to like start a class to create a list. Um, Typically, what's more native to those languages are stuff like arrays, which in Java or C Sharp, they're different than what lists are. Arrays can't change their size, but Python, it does allow us to do that. We're able to change the sizing, add more stuff to it, remove stuff from it, and it's able to change dynamically. If you're familiar with JavaScript, you might have also heard the term of array. Um, Really, I don't know why it's called an array, because it's more closely related to a list. Typically, the actual definition of an array is a collection of values that is preset or predefined. An array actually has like if you create an array that holds 5 items, that is it. That array will only hold 5 items, um, and you can't add any more. So I don't know why JavaScript calls it arrays, if I'm being honest with you. But really, if you're familiar with JavaScript, arrays and lists are going to be the exact same, the way that they work, right? So it shouldn't be too foreign for you if you're coming from the JavaScript side. So here we have our first example of a list. So they say list is equal to 1, 2, 3, 4, 5. And to be fair, this is not good. I should probably update this. You want to when you create a list, you don't want to call it list, right? You want to avoid these keywords, right? So you shouldn't call something list, because that's the keyword for it. So I don't know why I did this, so I apologize. But they should say something like list underscore one. And here we create a list and assign it to a variable name of list one. And when we print it out, we see that we print out the entire list and it holds 5 different values: 1, 2, 3, 4, 5.
Would you say calling it a list is like saying calling a person human? Like you don't call them what they are?
Um, Yes and no. The reason why you don't want to do that though, Jose, is because you might overwrite the definition for it. I don't know if it does it with lists. I know there's other keywords that you are able to overwrite what's assigned to that name, and then it might give you an error. So you typically don't want to use keywords, so you avoid any kind of weird functionality like that. That's why the naming convention of these variables should be like list underscore one to specify that this is just one list, right? This is a very abstract name here. You're just calling it list one, but you don't want to just call it list. That is not good.
Gotcha. Okay.
So lists, they can hold multiple values, but they can also hold multiple different data types, right? So not only can they hold a list of numbers, we're also able to hold strings. Now, keep in mind, if you're going to put a string, you still have to make sure that you uh, declare that the item at that specific position is a string by giving it quotation marks, right? And we see that here, right? We have a string list with 3 different strings. I love Python. And all 3 of these strings have their own individual quotation marks, right? And you have to make sure that they all have their individual open and closing ones, because if I were to remove these quotation marks, technically this is one string at index 0, right? That now makes this list only have one item, which is one big string called I love Python. Even though there's commas in here, because there is an open quotation mark here, no other quotation marks within here, and then a closing quotation mark here, is going to take this entire thing as one string, right? So when you add strings into your list, ensure that they all have their individual open and close quotation marks, whether they're single or double, to ensure that each individual value within your list is its own unique string. And we can run it and see here that we do get our list of different strings. So not only can we hold strings and integers, but lists can also have other lists saved within them, right? So different data types, and we can even hold data structures, right? We see here we have list with lists. It has the three strings A, B, and C, index 0, 1, and 2. And index 3 is holding an entire other list with its own individual values within here, right? It is not foreign to see nested data structures, right? And that's really what we call it nested to specify that they're within each other. So you will be seeing a lot of lists within lists. We have yet to talk about dictionaries. That'll be Monday, but it is not uncommon to see lists within dictionaries, dictionaries within lists, vice versa, in a wide range of nested data structures. All right. So just be aware of that. So if any questions about
Yeah.
lists,
So just to clarify, DEF is the list inside of this list?
yes.
Okay, thank you.
And we'll talk about a little bit more about how to handle these later on. But I want to make you aware that because this is its own unique list, the value of D is at index 0. Although the entire list itself is at index 3, the position of the value of D, which is inside its own list, is at index 0 within this nested list. So be aware of that. They get their own position within the corresponding list that they exist in. We'll talk about how we access those.
So
Yes.
Roger, on that one, on that line right there, where lists within lists, is there, or will you be covering it a little later, that second list having its own name?
It actually does not have its own name. It does not have a variable that it belongs to. This list exists within this list that is saved into this variable called list with list. So it technically does not have a name. It does not have a variable that it belongs to directly.
Just
Right?
an
It is,
index, right?
yeah, it belongs to an
Just its
index
yeah, okay.
position. Thank you for that, David. Yes, it is just at an index. So you wouldn't be able to access this nested list with a variable name because it doesn't have one, right? There is a way to access it using the variable name of its parent list. And you're going to hear that terminology very often in coding. You might hear the terminology of parents and children. But the parent list is who it belongs to. This list belongs to the parent of lists with lists. And I see a question. Does yes, does DEF list have an index? Yes, it is at index 3, right? The D is at index 0 within this nested list, and then we'll talk about how we can access those values in a little bit.
So E does not have a index location in the first list, only in the DEF list.
Correct.
Okay.
All right, so list operations and methods. All right, so here we have a list called travel bucket list, and it is a long list of different places where we will wish to travel one day. We print it out, and here it is. Now I'm doing this just so I can save it in memory, but now that I think about it, we saw that on Monday that it doesn't matter. But let's talk about different ways of how we can work with lists. Right. So accessing the elements in a list is going to be the exact same way that we access the different characters within a string. So a string isn't necessarily a list, right? A string is a sequence of characters. But by definition, so is a list. A list is also a sequence of different values. Now they hold different things. One is a list of characters, while one is a list of different values, right? And the values could be anything. It could be other characters, it could be other lists, it could be data structures. Um, they're both sequences, but they both have different things within their sequence, right? But at the same time, you're still able to access them the same, right? So the same way that we are grabbing the different characters inside of a string, we're going to do something very similar on lists using, once again, bracket notation, right? So when trying to access a certain point in a list, you're going to call the list name and you're going to follow it by some open and close square brackets. Within the square bracket, you're going to pass in the index of the value that you're trying to access, right? And you see that a quick little snippet here of what that looks like. List variable at index n is supposed to be a number, right? Hence the n. So that's how you access the items of a list. Now, what if you wanted to change something within a list? Well, first and foremost, you have to call the index of the value you're trying to change. And then you're going to reassign its value by using the equal sign. The same way that when you assign a value to a variable, you're going to do that here. The only difference is you have to specify the index of the value you're trying to change. Do I have any questions about accessing or setting the items at a specific index? Awesome. Here's another concept here, which we're going to talk about in a little bit too. But the same way that we're able to grab certain parts of a string using the bracket notation specifying the start and the stop, we can do the exact same thing for a list, right? Same syntax. The first value passed in is the start. The second value is the stop. And there is an optional step value that by default is set to 1, right? It's an optional one, so you don't have to pass it in there. By default, we'll always just step over 1 time. But just be aware that that is something you could do. So we defined our list of travel bucket list above. We want to grab the item at index 4. So 0, 1, 2, 3, 4. So they should return to me Fiji. And it does so. Here, we see that we are slicing a list, or this is actually wrong. Why is it this way? Okay, I want you to ignore this comment. So let me go ahead and remove it. This really is supposed to be reversing a list. So I do apologize for that grammatical error here. But here, the same way that we saw on Monday, I believe, about how we were able to reverse a string, we can do the exact same thing, right? But we don't specify the start and the stop, but we come back backwards using the -1. And this is going to reverse your list here. And as you saw above, the first value was New Zealand. And this time, New Zealand is at the back. And what was in the back is now in the front. So we were able to do that with strings. We can also do that with lists. Now, assigning a new value to a specific index, as I mentioned to you guys before, you're going to want to call the list that you're trying to access and then pass in the index that you're trying to grab or change. Like you see here, we're trying to access the item at index 4, and then we're going to give it a new value of Texas. And then we're going to print travel bucket list. And we see here 0, 1, 2, 3, 4. So index 4 was changed to Texas. And I believe Fiji was here before, now it's Texas. Do you have any questions about how we're going to grab an item from a list, how we can reverse it, how we can change it?
So you, in that last one, you completely replaced Fiji with Texas. is there a way to just add Texas in addition to
Yes, and
the
we'll get
list?
that
Because
to
that's what I thought that line was doing. Is I thought that was just adding Texas to the list. I didn't catch that it completely took Fiji out of it until you just said something.
Sure. So there is a way to add it to the list, which we will get to here quite shortly.
Okay.
But this is going to change the value at index 4, right? We are quite
Okay.
literally specifying, hey, I want the list travel bucket list, and I want the item at index 4 to equal to the value of Texas, right? So notice how that is structured. We are saying that the item at index 4 is going to equal to Texas. So we specify a very unique location, and we are assigning it using the equal sign a whole new different value, which is why it changes it, but not adds to it, right? Because we didn't add, we specified a location and assigned it a new value. Make sense, Todd?
Yeah, it sure does. Thanks.
No problem. So this here said it was slicing a string, which is wrong. It's supposed to be this is reversing a string. Well, let's talk about slicing, right? Because that's still important. So just like we were able to grab a very specific point of our list, I'm sorry, I misspoke. A very specific point of our string, we could do that with a list. So I'm gonna go ahead and I'm gonna print out travel. Actually, I'll create a new variable instead. I'll say partial list is equal to, and I'm gonna grab travel bucket list, and I'm gonna grab everything from index 1 up to index 4, but not including index 4. All right, so up to, but not including. So if I'm saying I'm grabbing index 1, that should be Antarctica, and I'm gonna go up to index 4, but not including. So I'm gonna say 1, 2, 3, and this is supposed to be 4, but as I mentioned, the stop is up to, but not including, so it's not going to include it, right? But it's gonna come up to it. So this should give me Antarctica, Italy, and Chile, or Chile, however you pronounce it. And then I can print out partial list. And we see here that I get those 3 items within my list.
Is there such thing as nested indexes? Like, can you index an item out of a list and then index a character out of that item or that value?
Yes, we will get to it in a little bit, but that is actually exactly how you're going to access a nested list like you saw up here. All right, I won't get too much in the weeds, but you would essentially grab this index and then you would grab the next index of whatever value you're trying to grab. But we'll talk about that later. But yes, there is a way. All right, so list operations. All right, so just like string uh, has different operations or methods that you could do with it, lists have the same thing. So len is one that you could use with strings, but you could also use it with lists. Some of you have probably already seen it. I think we saw it with strings. I'm not quite sure. But len is short for length. Karen, nice dog. But we want to grab the length of this list, right? Len is going to take in some kind of value, right? Usually some kind of string, a data structure like a list, or it can even grab a dictionary, which we will get to later on. And it's going to count every single value within there and return to you the size of that value. All right, so here we have travel bucket list, and we are using the length method. I'm gonna assign the value that comes back to this from to a variable. So I'm gonna say length of list is equal to whatever comes back from this len method, and then I'm gonna print length of list. And as you see here, I get back 7. Is that correct? Well, let's look at it. We have 1, 2, 3, 4, 5, 6, 7. Something that you might notice here. Length does not use index notation, right? When we're checking the placement of something, we start at 0. But when we're trying to count the values of something, of how many times something appears or however long it is, we start at 1 like normal. All right, so just be aware of that. There is a difference there when grabbing the length or using index to check position. When we check position, we use 0 index notation. When we're trying to grab how big something is or how long it is, we're using regular number conventions like 1, 2, 3, and so on. So it was able to return to me however long this list is, which is 7. So have any questions on the len method?
Is there an easy way to remember when it needs to be passed as an argument versus calling it like you would a method or a class with the dot?
That's a good question. Um, how can
Sorry, can you
I?
repeat that question? Or Roger, can you rephrase it?
Yeah, so he's asking, and that's a very valid question. So if you look at this function or this method called len, it's taking a value inside of it, right? It's working as a function. We saw that yesterday. When we created a function, we gave it a name and parameters, and when we were ready to use it, we called the name of the function and passed in the parameters like you see here. But then you also have other methods like, let's say string 1 is equal to Roger, right? And I can say capitalized name is equal to string 1 dot title, right? Notice that unlike the len function, that I had to call the function itself and then pass in an argument, here I called the variable and then called in the method I wanted to use. So he's asking, how do I know how I'm supposed to do it? Am I supposed to call it like a function, or am I supposed to use it like a method? Uh, and to be completely honest with you, you're not going to be happy with the answer, but really you just have to learn how to use them. If I'm being honest with you, I can't think of anything off the top of my head. Um, if you get an error, chances are you're probably using it wrong. Uh, but I would say maybe let's look at. Hmm, I would say maybe how it works. Here, the length method or the length function took a value and it did nothing with the value necessarily. It didn't change it or anything. It just returned to you a number. So it did some kind of operation where the dot title, it returned to you a copy of the original value that's changed. So maybe there's some connection there, right? Maybe it's how they work, if it helps you remember. But really, I don't have a good answer for you, which I do apologize. Um, I will get back to you on our break to see if I can find a valid answer for you. Um, the short answer, which is not the ideal answer, which I do apologize, is just getting familiar with these methods or functions and understand how they work. Um, and that's going to come down with practice, right? Being in a situation where you're required to use them, so you're using them and you get used to it with time, really. Um, that's the only thing that can come to my head, really, is just practice. Um, right? It's like you asking me like how is there a way how to remember how to assign a variable besides just remembering how to do it. I can't think of a way to answer that question. I do apologize if that's not a good answer. But do make it easier for yourself and put yourself in these situations, which kind of goes back to something I was talking about. I think it was with Thomas. right? Um, Really, you know, when working with these exercises, challenges, you might feel inclined to want to use ChatGPT or AI, right? It's very simple to ask AI, can you solve this answer for me or give me the solution? And it's going to give it to you. And that's not really going to do anything, right? The thing with coding is that you have to put yourself in a situation where you're forced to problem solve and think critically. Because really, anybody can just memorize the syntax and methods and the way stuff is structured. But if you don't know how to break a problem apart or how to think critically or problem solve, um, you're not going to be successful. Um, and problem solving and critical thinking isn't a skill I can really teach you. It's something that you end up acquiring through not only trial and error, but really being exposed to it and being put in a situation where you're forced to think critically, right? Where you're forced to having to read through the prompt, right? Understand what the question is asking of you, breaking the question into smaller problems, tackling a problem at at a time, um, encountering an issue that you don't know how to solve, and then, and only then, is it a good idea to ask ChatGPT, hey, I'm trying to change the value of this list in Python, but I don't remember exactly how it's done. Or, hey, I want to know the length of this list or this data structure, but I don't remember if Python has a built-in function that does this. Is there a way of doing this? Right. And then, because you put yourself in a situation where you have to solve a problem, you find out that there is different ways of doing it, and you end up acquiring tools that are going to make you successful. Um, so really, it's going to come down with time and trial and error, experience, and exposing yourself to these situations where you have to problem solve. That's probably the best answer I can give you. But all right, let's go ahead and move forward. So yesterday we started talking about conditional logic, and we even talked about comparisons and membership checks. Well, the same way that you can check if a letter is inside of a string, you can do that with a list. Right here, we are printing out the result that comes back from a membership check. They should look a little familiar from yesterday, right? We're saying Fiji in travel bucket list. And if you guys recall, when using membership checks like in, not in, it's going to return to you a Boolean. So this is saying it's Fiji inside of travel bucket list. And it's going to say true or false. And the same thing with Texas. It's going to give us back a Boolean. And we get false for Fiji because if you recall, we changed the value earlier to Texas. So the first line gives us false, but the second line gives us true. So you are able to use membership checks to see if something exists within a list. Now, I want to give a word of caution. And this is really more for down the line. But when you guys start thinking about, the complexity of your code, how effective it is, you're going to know, or you're going to be taught that for loops increase the time complexity in your code. And without getting too much into the weeds, the reason why it increases how much work your computer has to do to solve that is because when you use a for loop or when you're trying to iterate through something, you're checking every individual item at a time from start to finish, right? So if your list is a million items long, it's going to take a million computations to find the answer in the event the last item is the item you're looking for, right? Because worst case scenario, let's say you're looking for the number 5 inside of this long list of numbers, right? Not the best analogy, but bear with me. If the item you're looking for is the very last item in the list, your computer is going to have to check a million different items until it finds the solution. So that increases the effectiveness of your code. It might not run as effective as you want it to. And I bring that up because using a membership check is going to do something very similar. Although you think it looks like magic, realistically, underneath the hood, By saying Fiji in travel bucket list is going to iterate through everything within this list and check every individual item until it finds what you're looking for. If it doesn't find it, by the time it finishes, it's going to tell you false. If it finds it on the first item, good stuff, good for you, you get true. But when we think about how efficient our code is, we typically tend to think about the worst case scenario. Now, that's not to scare you to not use this. This is a valid way of using it. Just be aware, depending on the scenario and the job you're working, if you're working with large sets of data and you're doing this very, very, very often, it might slow down your code, right? Once again, I'm not trying to scare you. Use this. This is a great way of checking if something exists in a list. I'm just trying to make you aware for the future. Sound good? All right. So strings, we talked about that there's some methods that you can use, right? We saw dot title, dot lower, dot upper, dot capitalize, dot find. Lists have their own built-in methods as well. And one thing that I want to add to that, a lot of these methods are going to be unique to the data structure or data type they are working with, right? Some of these methods won't work on everything that you use. So if you find yourself trying to use a method like dot clear, right? Remove all the items from the list. This will not work on a string. So I just want to make sure I give that disclaimer. If you're trying to use some kind of method, know that some of these methods are data structure or data type specific. So they don't work for everything. But at the same time, there's a lot of methods that do work for multiple different types of values or data structures. So here is the very first one, the very first method that you're going to find probably the most useful with lists, and that's going to be how to add things to a list, right? That's going to be your dot append, right? So to append really is just to add something to a list, right? You're appending it to the end of the list. And to do that, you're going to call the list you're trying to add to, right? You're going to follow it by the dot append method. And inside of the method, you're going to pass in the value that you're trying to add. This by default is going to add the item to the end of the list. Be aware of that. It's going to add it to the end of the list. Lists, once again, are ordered data structures, so they all have a position. We have another one here called list.extend. It's quite similar to the dot append, except instead of taking a single value and adding it to the end, it takes multiple values, right, in the form of an iterable. Does anybody know what the word iterable means?
Something you can cycle through.
Yeah, Dante, cheater, you've been here before. Something that you can cycle through, right? Something you can iterate through, right? A string, you can go through every individual character, right? We haven't gotten to it yet, but with for loops, we're gonna see that we can grab every single character. We can cycle through every individual character using a loop, right? A list, you can do the same, and you can do the exact same thing with a dictionary, right? So that is what an iterable is. An iterable is something you can iterate through one item at a time. So that means this method here takes in an iterable. So if you pass in a single value like the number 5, it won't work. You need to pass in an iterable, ideally another list itself, right? What this does is going to take this list, is going to grab every individual item, is going to add it one item at a time to the end of the list that you're calling it. So this is a list that's calling it. So it's going to grab everything within the iterable and it's going to add it to this list, right? So the item that's getting new stuff is the one that's going to call the method, right? The item passed in as an argument, that's what's going to be split up and added to the additional list that's being called upon. So this is going to extend the list by appending elements from the iterable, right? If you try to use the dot extend method on something that's not an iterable, you're going to get an error. Can tuples be appended to a list? Yes, you can. You can add pretty much any data type or data structure into a list. We'll get to tuples in a little bit. So the next method we see here is going to be the list dot insert. All right, so this is very similar to the append, except it gives you some additional functionality, right? The list dot insert is going to allow you to add a value to a specific position in your list, right? Now, not to get confused with what we saw earlier when we changed Fiji to Texas, right? This won't delete the item that is at that specific index. What it's going to do is it's going to push everything to the right and it's going to free up that space and add it there, right? So when you use the insert method, it won't delete it. But if you try to call the index and reassign the value, it will remove that value and replace it with a new one, right? So it's two different functionalities here. The next one here is the list.clear, which is just removing all the items from the list. Really, you can just reassign what's assigned to that list with an empty list, or you can use the dot clear method, whichever way you like to do it, right? And by what I mean by that is that we have list one is equal to 1, 2, 3. You could say list one dot clear, or you could say list one is equal to open and close square brackets. So either one of this really is going to clear your list. The difference between this is, I believe, list one dot clear isn't going to recreate a new list. It's going to keep that list intact, but it's going to remove everything from it. Where the list one is equal to square brackets, this is going to reassign a whole new list to it, and it's going to be empty. Now, which one you use here, really, it doesn't matter. Whichever one you feel comfortable with. I've never used dot clear. It's easier for me just to assign it a new empty list. To be completely honest with you, I even forget that this method exists sometimes. So, not one that you really have to have in the back of your pocket. If the ones that we've covered, if I had to give you a recommendation, the one that you really care about is going to be the dot append and the dot insert, right? Those are going to be some very good methods to use.
With dot clear, are you allowed to specify a range of indices that you want to clear, or does it just blanket statement clear the whole thing?
That is a good question, and I think it clears the whole thing. But let's check it out. Let's go to definition. And of course, it gives me absolutely nothing. W3 schools, Python dot clear. It just clears the whole thing. There's no additional parameters. That's a
Oh,
good question.
wow. Yeah, that truly is kind of useless then.
Yeah, so whichever method you decide to go with, just choose one and just stick to it. All right. So the next very important one. This is another one that you might want to have in the back of your pocket or write down if you guys are the people that write notes. It's going to be the dot index method here. Right, the dot index method is going to return the index of the first item with a specific value. So the way that it works is you're going to call the list that you're trying to search through, and you're going to use the dot index method and pass in the value you're trying to look for. Now, this is a little bit different than using the in check, right? Using a membership check. The membership check checks every individual item until it finds it. The dot index method does not. It's going to go directly. Actually, I take that back. I'm wrong. They work the same thing. I don't know why I was getting confused. Hold on, give me a second. I got a cough. My kid got sick. But I take everything I just said back. They're gonna work the exact same way. Doodle, is that how you pronounce your name? Can you
Oh yeah,
remove I see your
that's how you pronounce the name. Sorry, I was trying to find the unmute button.
sure.
Yeah, my question was if you could remove a single variable from a list.
Yes. I don't see here. We'll talk about it in a little bit, but yes, there is a way. There's multiple ways of removing items. That
All
will
right,
come.
perfect. I'll sit tight.
Yeah, no problem. So we're able to return the index of the first item with a specific value. I took back what I said. This is going to iterate every single item until it finds it, but it's going to stop at the first item that it finds. Just be aware of that. The dot count method is the next one, and this is another very good one. It's going to return the number of times a specific value appears in the list. Um, so if you have a list of different numbers and you're trying to find how many times the number 5 appears, you would pass in the 5 within the count method, and it's going to return to the amount of occurrences. It's another good one. Here's another good one that you will probably find useful. And it's going to be the dot sort method. The dot sort method is going to sort the list in place, right? So it won't recreate a new list is what that means, right? So you are able to pass in you'll call the list and you call the dot sort, and it's going to sort it for you in ascending order. Now there is a way to reverse that. I don't remember the exact syntax for it, but you can change how you sort it if you wish. I don't use the additional method often, but here we go. The reverse parameter. So reverse is equal to true will sort the list descending. Right, the default is it's set to false. So when you use the dot sort method, it'll by default sort it from left to right in ascending order. And then you are able to pass in a function as well. Right, we see here the other argument that you can pass in is a function to specify sorting criteria. So let's see, how can I demonstrate that? I don't use this method often. Oh, that's my work. So let's see if I can show you how that works. So let's go ahead and create list one is equal to. And I'm going to say list one dot sort. And I'm going to say reverse is equal to false. So I can give it that second argument. And if we saw here, we have a function. Now, this is the first time I actually do this, so bear with me. I might get this wrong. But let's create a function. I'm going to say define sort evens. And we'll say it's going to take in a list list of nums. I don't know if this is going to work, but we'll say let's try it out. Let's say actually num. If num modulus 2 is equal to 0, return num. Let's see if this works. If not, I'll try it out during the break. Key is equal to sort evens. Print list one. I'm putting myself in a very vulnerable spot. Let's see how this works. And it did not work. Oh. What if we pass in list of, or what if we don't pass anything? I guess we do have to pass in something here. List of nums. And let's pass in list one. We'll say for num and list of nums. If num modulus 2 is equal to 0, return num. an object is not callable. Okay, I'll get to it in a little bit. I'm gonna see if I can solve it, but you should be able to pass in a function here, and you pretty much set like criteria of how you want to sort it. I know this should be possible, so you should be able to like, for example, here, I'm gonna sort it where I prioritize stuff that is even over what's odd. So we'll see how this works in a little bit. But time is 6:59. I'm gonna go ahead and put you on a 10-minute break. And then during that 10-minute break, I'll see if I can get this working. All right. So you can see how it works. We'll be back in a little bit. Let's come back at 7:10. So before we went on break, I was talking about creating a customized function to sort our list here. So I was able to be successful after a couple tries. And I see here that we have a sort evens function that I created. It's going to return the remainder of that number that's passed in. We see here that it takes a number, it does the modulus operator of 2 on it. So that means it's going to divide it by 2, and it's going to return to me how much is left over, right? And as we know, even numbers are easily divisible by 2. So if it returns 0 to me, I know it's even. And if it returns anything greater than 0, it's going to be 1, right? Because there's probably going to be something left over. And that's going to mean it's odd. So when this function runs, it's going to use this pre-built function I've made as the sorting criteria. By default, when the dot sort method runs, and this is a little over your head, that's okay. You don't need to get too complex with it. I just want to show you how it's done. But the dot sort method is going to go through every individual item at a time, like a loop. It's going to iterate through our list and grab each item. Because I passed in a function, it's going to automatically pass in the number that's iterating through into my function, which is why I don't have to specify anything here. The dot sort method is doing all the heavy lifting. It's a very unique case. Not all functions do this. So don't get confused here. But the dot sort method, the way that's working under the hood is automatically going to pass in my num into my function. And it's going to divide it by the 2 and return the remainder. Now the dot sort method, because it's set to ascending order, is going to prioritize lower numbers over higher numbers. So if it's a 0, it's going to return that, and it knows it's going to sort it first. If it's a 1, it's going to push it to the side, right? Which ends up returning this sorted list where I prioritize even numbers for first from 2, 4, 6, 8, and then I prioritize the odd numbers. So you don't have to really know how this is working right now. The main point of this exercise was to show you how these different methods have different ways of working. And really, if you want to familiarize yourself with them, you kind of have to mess around with them, look into them, and try it out. There's not going to be many scenarios where we're going to have to specify a very specific way of sorting something. I'm just showing you that it is a solution or something that you could do. All right. So the next thing we're going to talk about here is an example of how we're appending values into a list. Notice they're calling the previous list we created travel bucket list, and they're using the dot append method. Right? They're passing in the string Germany, and if we print out our travel bucket list, we're going to see that's going to add Germany to the back of our list here. All right. So as I mentioned to you before, the dot append method is going to by default add it to the very back of your list. But this is how you add items. It's actually not as common to as you think to have to specify where you want to insert a value into a list. I've done it a couple times, but typically you're not really too worried about the order of your stuff inside of a list. I've done it a handful of times, but it's nothing to stress about too much. The next method you see here is the dot extend method, which is another version of adding items to a list. But as you remember, as I mentioned to you before, it's going to take an iterable. So here it's going to take a list, which is an iterable, right? It has items that you can iterate through in the form of a sequence, as Argentina, Thailand, and Australia. We're going to extend our original list with this list being passed into extend. And we see here that Australia, Thailand, and Argentina are added to the back of the list. So it did successfully extend it. Here's the other way of adding things, right? You mentioned the inserts, right? As it stands right now, New Zealand is at index 0. But when I run the insert method, I'm specifying that I want to insert at index 0 and I want to insert Canada. When I run this, it's going to add Canada to the front of the list and it's going to push everything to the side one index over. If I said, index 5, that it would do as such. It's going to move it to the 5 and push everything from 5 and onwards to the right. So we have multiple ways of how we can add things to a list. And this here is just showing you how this works. So here we're using the dot append method, but notice that we're passing in an iterable. It is a list of 2 different strings. Is this going to work?
No.
It will. As I mentioned to you guys before, lists can hold different types of things. They can hold strings, numbers, other lists, even dictionaries. So it wouldn't work if I said something like this, Peru, comma, Argentina. Right? Because I'm passing in 2 different values here, 2 different strings. Earlier, this is actually one whole value. That one whole value is this list itself. Right? So although this is 2 items in a list, the entire thing itself is just one item, one whole list. So it will work, but notice it's going to append the whole thing as it is. It takes one item.
So does that become its own index as well then? Am
Come
I saying
again?
that right? Does that become its own index as well? Am I saying that right?
Correct. It will be its own
Okay,
index.
gotcha.
John B, what error are you getting when you run the last 3 exercises or examples? Name error. Uh, Chances are you forgot to run one of the methods above and got an issue. It happened to me before. I didn't think it was going to be an issue, but if you have an issue with it, you might want to run every other block beforehand, so some of these could work. Uh, I didn't see any issue before, but if you're getting a name error issue, what is it referring to? What is giving you the name error? Is it saying travel bucket list is the name error? If so, then it doesn't recognize travel bucket list to be declared. So you're gonna have to run the blocks to ensure that it's tracking that you have declared these variables. And I'm glad you got that issue because I was so confused when I ran it. I think Monday, and I was like, why is it showing me this if I haven't ran the variable yet? So make sure you run all the other code blocks beforehand, so it's tracking that you declare the travel bucket list. It's really it's just a Jupyter Notebooks thing. So I do apologize. If it helps, I would just copy and paste the code block you're trying to work on and put it into practice.py, and run it there. Awesome. So where did I leave off? We append it, we extend it. Oh, so we saw here how this works. Now, is this going to work? Lami, you want to take a guess? Is this going to work?
Yes.
Yes, it is going to work.
It's just gonna add the
But
letters, right? Individually.
yes, it's going to add it individually. It's going to treat it as an iterable because it is an iterable. A string is an iterable. All right, so we see here it's going to add Japan, but I'm pretty sure if I add 7, this is where you get the error. because 7 is not an iterable, it is one specific value. Where a string, although it's one value, as I mentioned to you guys before, it's still an iterable. It is a sequence of characters, right? It is a sequence of characters. Whereas a number is not a sequence of characters. So just be aware of that. All right. So, all right. The next thing we're going to talk about is removing items from a list. It was asked about to me earlier, but the same way that we can add things to a list to manipulate it, we can extend it. We can also remove things that we don't want. Now, there's two ways of doing this. There is the dot remove, or there is the pop. Now, which one you use is going to dictate on what you're trying to achieve. Both of these do something a little bit different than the other. These are both going to remove an item, right? The dot remove is going to take the first appearance of X, is going to remove it from your list. The pop I is going to remove the item at the index, right? So you're not passing the value itself. Excuse me, I burped. You're going to specify the index of the item you're trying to remove, right? Notice this here. We're using the dot remove method. We're passing in the value that we are trying to remove specifically. I don't know where it's at. It could be anywhere in my list. We're not passing an index. We're passing the value that's at the index, right? And then I'm going to print out travel bucket list here. But when I run this, I removed the GAP and the N from Japan, but I left the A, right? So I specified the value I was trying to remove, no index here, just the value, and it was able to remove the value. Now, let's go ahead and use the dot remove again. Now remove that A, which is good. We don't have Japan all weird in here. Now, the pop method has a very specific way of working. The pop method, not only is it going to remove what you're trying to remove, but it's going to return it to you. So you are able to save it into a variable, right? So here we're calling the travel bucket list and we're using the dot pop method. Notice we're not passing in a value, we're passing in the index. We're trying to remove the item at index -1. What is currently right now at index -1?
Dominican Republic.
Yeah, oh, not exactly. Peru,
list.
yeah, the list of where Dominican Republic is at, as well as Peru, right? So it's going to remove the entire thing. That is -1. You're on the right track, but it's going to treat this whole item as one thing, right?
Okay.
So it's going to remove that, but when it removes it, it's also going to return it to us. So we're able to do something like this, where we can create a variable here called spouse bucket list. And then we can print out spouse bucket list, and we can see that it not only removes it, but it's also going to save it into a different variable. So let me print out travel bucket list as well, so you can see both of how they look. So the travel bucket list, after we run the dot pop method, it successfully removed that list, but we also assigned it to a variable when we did that. And we see here that we were able to print out that variable to give us the value that we removed. The dot remove method does not do that, right? The dot remove method is going to just remove it and you lose it. To show you that, I can say dot remove here, and I'm gonna pass in Australia. And I'm going to try to save it to removed item is equal to print removed item. And you see here, the value that's in removed item is none. This variable has nothing here. The dot remove method does not return it back to you. It will remove it, but it won't be in here anymore. It won't save anywhere. Let's go ahead and print travel bucket list again. You see here the Australia is no longer present. So it does remove it, but it won't save it. So uh, which one you use is going to be dependent on the scenario, whether you're still trying to keep track of the value after remove it from a list or not. If you don't care for it, you can just use the remove method. If you want to save it, you want to use the .pop method and call the index of the item you're trying to remove while assigning it to a variable. So it's going to be situation dependent. But both of them have their purpose and time and place. So be aware of both of them. They're very helpful. It's going to help you out in the future. So we talked about the dot index and dot count method, but let's see how they work. Right, so here we have Texas. It's still in the list. And when I call the travel bucket list, I can say dot index, and I'm going to pass in the value of that I'm trying to look for to get what index it exists in. And it's going to say 5. And if I count here 0, 1, 2, 3, 4, 5, I see here that Texas does exist at index 5. So the dot index method will return to you the index of the value you're trying to pass in. The dot count method is going to count how many times something appears in your list. And because Texas only exists once, we're going to get 1 back. So both of these are very helpful methods as well to have in the back of your pocket. So make sure that you remember this. So if any questions about dot index or dot count. Awesome. All right, the next 2 methods here is dot sort, and you didn't see it in the table earlier, but we also have the sorted method, right? Both of these allow you to sort the list or the iterable to how you want it to. But the way that you call them and the way they're used are different. The dot sort method is going to be called as a method, right? That means you're going to call the list and you're going to append the dot sort method at the end, right? This is going to sort your list in place, right? That means it's not going to create a new variable. It's going to take the original variable and it's going to sort it, right? And if I run this, we see here, it's going to sort my list in reverse because I have the keyword reverse is equal to true set. So it's in reverse order. I can see Argentina and Antarctica at their very bottom because they're the A, followed by the C's, and so on and so forth. So I was able to sort it in place, right? I didn't assign it to a new variable. I didn't create a new list. I called the list itself and I invoked the dot sort method. Now the sorted method works a little bit different, right? The sorted method, it does not run it in place. It does not manipulate the original list, right? The sorted method is going to work as a function, not a method. That means you have to call the sorted function and pass in the arguments that you want, right? And I think maybe this is a huge identifier. I don't know who asked about how to call methods or functions, whether you're going to append it or call it the function. But this is a prime example of what I was talking about. The dot sort method mutated or change your value in a sorted method here. I'm having to create new variables, so maybe that's an identifier here of how they work or which one you want to use. But sorted method here, it takes in the travel bucket list. It also has the keyword of reverse if you want to set it. But we are going to assign this to another list called other sorted travel bucket list. And now when I run this, let me set this to false so we can see this. When I run this, I print out the travel bucket list first, right? My original. Notice it's still reversed here from above, right? Because we call the reverse method here on the original. So the original is still reversed in descending order, with the T being last, I'm sorry, the T being first and the A being last. When I use the sorted method on my original list, I assigned it to another variable, and I printed that other variable as well. This one did sort it how it should be, right? Reverse is equal to false. But notice that I got two different inputs for both of these. The original stayed the same, right? The sorted method is not going to sort it in place. It's not going to change the original list. It's going to essentially make a copy, sort it how you specify to sort it, and then save that copy into a different variable, right? But it will not mutate the original list, right? It will stay the same. So if you plan to use the sorted method to receive a copy of the original that's sorted without changing the original, you want to use a sorted method. If you don't care about the original and you just want to sort it, it is what it is. I don't care. I don't ever need the original list. You could use the sort method instead. So which one you choose can depend on the scenario, on whether you want to keep the original list the way that it is, or if you don't care about it. Do I
What
have any?
other inputs could you use to sort out of curiosity, like, for a parameter other than reverse equaling true or false?
I showed you guys earlier, which is going to be the key method here, right? That's going to take in that specific function that you can declare. So it takes in reverse or it takes in a function.
Okay, that's right. Thank you.
No problem. Okay, I have to use the restroom real quick because I didn't actually take my break. So real quick, while I use the restroom, go ahead and work on the small little exercise. Really, just mess around with the list, right? Create empty list, add some items into it. All right, remove some items, sort it, reverse sort, mess around with the functions, get a little practice on there for the next 5 minutes, and then we'll come back and restart.
You muted.
I hate when I do that. I'm gonna do that more often. Just wait. But thank you guys for keeping me on track. All right, so let's go ahead and come back. We are going to continue from where we left off. We just finished our first set of ordered data structure, which was list. The next thing we're going to cover is going to be tuples, right? So tuples. Tuples are another form of ordered collections similar to lists with a very key distinct difference. That difference is the fact that they are immutable, right? That means they cannot change, right? Unlike lists that we're able to add and remove it with these certain methods and change the positions of stuff, uh, tuples don't work that way. Tuples have a very distinct way of being identified. That's going to be the parentheses around them. So here we have two ways that you can create a tuple, right? The two ways differ by the amount of items within them. A tuple, we see here we have tuple one, is going to be created by using the open and close parentheses here. And it's going to take in your values, right? This will create a tuple. Now, if you have a tuple that should only have one item, which really I don't know a situation of where you would have that, you would use a comma to specify that you want this tuple to have one item within it. This is the only way of doing it this way. If you try to do a tuple without this comma here, you're gonna get an error. I can print these out. Tuple one and tuple two. All right, we see here 1, 2, 3, and then we see the 4. Really, there's actually two items here. I think this is just like an empty value. But if you try to remove this, you're going to see that it does not become a tuple. So just be aware of that. Really, you don't need to make a tuple with only one item, but I just want to show you how you would do it if you needed to. Right, so tuples are very helpful when you have some form of data type, or I'm sorry, data value that you don't want to change, right? And here we see some small examples. Days of the week, right? The days of the week have never changed, right? Monday, Wednesday, Saturday, they're all the same, They stay consistent. Another version of when you might want to use a tuple is when holding grid coordinates, right? So like if I had the grid coordinate to the specific spot of where I'm at, that doesn't change, right? The size of the Earth isn't expanding or shrinking. So the the coordinate for my location will probably stay consistent. All right, so when you have data like that you're working with, a tuple is a nice data structure that you could use to ensure that people aren't changing it. Now, there are a couple things that you could use with tuples. Here we see that we have a coordinate set, which is 3 and 4. We are able to see how long a tuple is by using the length method, right? Just like we were able to do with lists or strings, we can still see how long a tuple is. We are able to check, right? A membership check here. If 5 is in coordinates, and if we see here, we get false being returned and set to is 5 present, right? So you are able to do membership checks as well. So there's not a lot of methods that go into tuples, but there are some handy ones that are accessible to you. So here we have a long list of tuples here, ranging from numbers from 1 through 678. They are in no specific order, but we have some methods here which I would say to take note of these methods. These is not just for tuples. These are built-in methods that you could use for lists as well that come very handy. And that's going to be the min, max, and sum. Right? We have yet to cover these, but these are methods that I've used very often during my career. It's going to quite literally take in some kind of data structure that has multiple values, so an iterable, right? And it's going to return to you, as the name implies, the minimum value of the items in there, the max, or as well as the sum, right? So here, this min method is able to identify that the lowest value here is 1. The max is going to return 678. And when using the sum method, it's able to go through every individual item, add it together, and return to me the total sum of all the values saved inside this tuple. So once again, the sum is very handy. You can use it not only for tuples, but also for lists. Do I have any questions on tuples so far?
Does that only work with numeric values? I know it sounds like a weird question because it says sum, but like what would happen if it had different kind of values within the tuple?
If you had, I believe, to the top of my head, if you had a list of strings, it'll return to by word count. Let's try it out. I'm pretty sure. My list is equal to a very short sentence. So I say print min my list. Pretty sure it's gonna return to you by word count. Yes. So we got A as the minimum. If we do max, we get, okay, that is not correct. Huh. Yeah, I guess that's not a very good way of using it, but I'm not getting an error, which is very confusing why I'm getting these. So min and max work, but it does not give you what you're looking for. So I would just keep it to integers. All right, but I knew you could like count letters or however long something is. I'm just confused on why the max got very instead of sentence.
Yeah,
That
that's odd.
can, yeah, that's a little weird. I don't even know what the heck is doing with that. How I even came up with that result.
I can't tell. Is there a space between the double quotation after very and the comma? Maybe. I don't know.
Could
I
you
think
add
No,
an
there's not.
addition of that, just like the string of Z and see if max returns Z because it might be going off of like alphabetical like position, like sort would?
Ooh, that's a very good observation. Let's try that. Max my list. And yo,
You're
spot
right.
on. Yo, who was that? Yo,
Going alphabetically.
Gold
Yeah.
Star, student of the month. Good job, man. That's pretty cool. Yeah, so it looks like it's going alphabetically wise. What it's looking like, it's probably taking the ASCII value, which actually, now that I think about it, ASCII table. I don't know if you guys are familiar with the ASCII table, but everything on your computer has a numerical representation. Um, this is not the correct table. Here we go. For example, the alphabet A through Z, they have their ASCII value, uh, which I want to say is the DEC. So A is equal to 65, right? Capital letter A is equal to 65, and lowercase a is 97. So technically, Z should be not as high. So Z capital letter will be less than lowercase a. So let's try this. This should now give me A as the max. No, it didn't. Okay. Um,
Well, yeah, because the lowercase v is still a higher value than the
yeah, you're
lowercase
right.
a.
Yeah, so it looks like it is going by ASCII values. So I think it not necessarily, I mean, yeah, I guess it still is going alphabetical wise, but I believe it's using the ASCII table, right? It's using its numerical value for that specific digit, I'm sorry, not digit, character, to know which one it should prioritize. So everything your computer has a numerical representation, from characters to numbers to even like certain keys. Like, where is it? Like the backspace, enter, all those. Here we go. You know, the escape. I thought there were more. No, is this escape? Yeah, escape, shift out, backspace right here. Uh, I don't see enter. But pretty much your computer uses this to identify what is what. Pretty cool to see. All right, let's go ahead and continue on. Other methods that we find is list, change the order of list or alter the elements. So this should not work. Why? Well, it's immutable, right? As I mentioned to you guys before, because tuples are immutable data structures, methods like sorts and sorted isn't something that's native to this data structure because it's immutable. You're not supposed to be able to change it, right? So the dot sort won't work. You see here we get an error. So here we have tuple 1 and tuple 2. Each one of these are their own individual values. We are able to concatenate tuples, but I want you to notice that we're creating a whole different tuples for them. Right, we're grabbing tuple 1 and we're adding tuple 2 and assigning it to tuple 3. And that gives us the combination of both of these tuples. All right. We can also run multiplication with it. Here we have all of tuple 1, which is 1, 2, 3. And we're going to multiply it by the value at tuple 2's index 0, which is 4. So we get 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So they grabbed this tuple, multiplied it 4 times because that's the value at index 0 of tuple 2, and they created one big tuple where 1, 2, 3 is repeated 3 additional times, ending up with 4. Do I
Question
have any?
about the adding them together,
Sure.
concatenating them. Could you just, to create tuple 3, could you just append tuple 1 with tuple 2?
You won't be able to do append.
Oh,
Append is
because
going
they're immutable, right?
correct.
Okay.
It does not have native methods like append or insert or anything like that. You couldn't access an index of the tuple like you're doing here in tuple 4, and then reassign it a value. Uh, using like E is equal to like 5, right? Because this, oh sorry, tuple 2 index 0 is equal to 5, because this will fail. First of all, you shouldn't be assigning values like this in line because this will fail anyways. But you can't do this right here where you try to change the index something because it is a tuple. Do I have any questions about tuples? All right. So, in conclusion, we talked about our data structures, Python lists, and tuples. We actually got through this lesson pretty quickly, which was awesome, faster than we've gone through any other lesson. So because of that, what we're going to do for this last hour, we are going to take this time to either work on any of the additional assignments or the extra exercises. With that in mind, because there's no actual any more lesson for today, uh, if you have to leave for the day, you are good to go. But class technically is not over until 9, so I will stay here and we will work through any assignments that you guys are working on. So you can stay here if you would like some additional help, ask questions. We can work through some of the problems. I can give you solutions. Or if you like, you could also go on your own and just work on them out by yourself. But that's
Could you
going to be
could you go over that first one right there? I kind of read ahead a little bit, and I don't know how to grab like the very first one on after the assignment, like right there. I'm having difficulty trying to figure out how to grab the index inside of it because there's no variables in where you're calling. So could you just like kind of go over that first assignment with us?
sure, absolutely. But before that, I do want to just dismiss the rest of you guys that don't want to work on assignments here or have anything else to do. So I'm going to go ahead and stop the recording.